Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, till now we have discussed about future engineering process. That is future engineering on numerical and categorical data and future scaling and future selection related to supervised and unsupervised techniques we have discussed. But before going into future engineering process or the exact data passing towards the future engineering, we want to know what is the exact data we are going to handle. See, actually data is increasing daily, and in order to understand useful information and gain insight from data, we need to analyze data. One or two or more variables can be used in data analysis. Also, the type of variable can be either numerical or categorical. And based on the number and type of the variable, there are different analysis techniques or that, dear friends. And yes, of course, today we are going to make this exploratory data analysis, but not performing that. Before going towards exploratory data analysis, we want to break down into various techniques that are there in exploratory data analysis, that is EDA. So both for numeric and categorical data. So we are just going to cover about the data and its analysis, covering univariate, bivariate and multivariate analysis. So let's drive in towards the functionality. Yes, dear friends. So yeah, before going on towards it, let me include the necessary libraries. Yeah, here I just execute it. Of course, you all just know this exact data. It is for data manipulation and data visualization, and this NumPy, it is for handling the arrays. And what is the exact data we are just going to use it? Yeah, it is all about a loan prediction data. Okay, so we want just going to use this loan prediction, and kindly just have a note of it. This is the exact one. See, actually loan prediction is a very common real life problem that every retail bank faces in their lending operation. If the loan approval process is automated, it can save a lot of man hours and improve the speed of the service to the customer. So the increase in customer satisfaction and saving in operational cost are significant. So however, the benefit can only be reaped if the bank has a robust model to accurately predict which customers loan should approve and which is to reject in order to minimize the risk of loan default. And yeah, here this is the exact features which we have, and yeah, we just discussed in detail one by one. And yeah, let I just load the exact data. So here it is, and of course by using that, yeah, we have just named it the variable as train data. And kindly just observe this, dear friend. Of course, we are just having this exact data. So here we are having loan status, yes or no. And yes, of course, this is exactly a classification problem where we have to predict whether a loan will be approved or not. So specifically, it is a binary classification problem. So where we have to predict either one of the two classes given, that is approved yes or not. Okay, another way to frame the problem is to predict whether the loan will likely to default or not. If it is likely to default, then the loan would not be approved, and vice versa. So the dependent variable or target variable is the loan status. So that is what, okay. While the rest are independent variable, which we just specify, these are our futures. And yeah, we need to exactly before developing a model or using this future or future engineering, yeah, we want to analyze it. So yeah, here we are just going to analyze this data. So kindly just have a note on towards this, dear friends. Here we have the shape. Yes. Yeah, of course, it has 614 rows with 13 columns is there. There is 13 columns of futures and 614 rows of records in this data, in this training data. And let me just have this info. Okay, so here it just provides us the information, and kindly just have a note on towards it, dear friends. This loan ID, it is a unique ID, and yeah, it is here in object. Okay, and coming towards this gender, yes, dear friend, it is a categorical, and yeah, of course, it is nominal, specified as like male and female, so that is what here it is an object. And this married, yes, it is also categorical name that is nominal, where the applicant married, yes or no, so that is what here it is an object. And next it is all about the dependents, and this dependent, yeah, it is a categorical and specified as ordinal, and number of dependents. So here number of dependents, yeah, you can just specify as 0, 1, 2, 3, but here this one among this data we have as like 3 plus. So see here this data, so here it just specify as like object data. And next we are having this education also a categorical, and it is specified in the nominal, that is as like applicant education, whether it is the graduate or undergraduate. And coming towards this self-employed, yeah, categorical and towards nominal, self-employed, yes or no, so that is what here object. And coming towards next, it is applicant income. Applicant income, it is a numerical continuous, and next it is co-applicant, that is also numerical continuous. And next it is all about loan amount term. So loan amount term, here we are just going to specify it in a discrete manner. So whether it is the term in loan of month, loan in months, so that is what here. And credit history, it is also categorical nominal, where credit history meets the guidelines, whether 0 or 1, that is what here we just specify. And coming towards this property area, it is also a categorical ordinal, and where it is specifying as like urban, semi-urban, rural. And last but not least, yeah, this is what our target loan status, that is a categorical nominal, and coming towards this loan status, that is approved, yes or no. So that is what here it is specified, dear friends. So kindly just have a note. And coming towards this, why I'm just specifying towards this data type. See, actually here we have 3 types of data: object, or integer, and float. And object format means variables or categorical. So categorical variables here we have as like loan ID, gender, married, dependents, so things are there. And coming towards this integer, of course the integer represents an integer variable, and one and only things applicant income is an integer format. And rest we have some float 64, that is it represents the variable which have some decimal values involved. Okay, so they also numerical variables. But why I'm just specifying this data types? Yes, of course, dear friends, see, data types are an important concept, because statistical methods can only be used with certain data types. You can have to analyze continuous data differently than categorical data, otherwise it would result in a wrong analysis. So therefore, knowing the types of data you are dealing with enables you to choose the correct methods of analysis. Okay, so yes, let me just we will first have a look onto that target variable, that is loan status. As it is a categorical variable, let us look at its frequency table. Okay, so percentage distribution, and have a plot of it. So that is what I have just listed here. So first of all, let me just have its frequency. So among its frequency, yes, loan approved, yes, it just comes 422, and coming towards no, the rejected things, it is 192. And let me just have an normalized data towards this, to have an percentage in distribution, and on plotting it, what we just get. So kindly just have, this is what. And yes, of course, dear friend, as I have already specified, the loan of 422, so around 69% of the people out of 614 was approved, and there is no imbalanced classes issues in this data set, and thus accuracy as an evaluation metric should be appropriate. On the other hand, if there are imbalanced or skewed classes, then we might need to use precision and recall as evaluation metrics. Of course, next we are just going to discuss about all these imbalanced and towards this evaluation metrics. So don't worry. So we are going towards this univariant. So yes, of course, dear friends, kindly just have one particular information which I just want to specify about this data. Yes, exactly. This is an univariant analysis, which is when we analyze each variable individually. So for categorical features, we can use frequency table or bar plot, which will calculate the number of each category in a particular variable. For numerical features, a histogram or a box plot can be used to look at the distribution of the variable. And with a histogram, you can check the central tendency of variability, modality, and kurtosis of a distribution. And note that a histogram can't show you if you have any outliers. So this is why we also use box plot. And to make it a summarization, I just start with this data analysis. So actually, first we are in this univariant process, and of course this univariant process we can just further divide it into numerical or in a categorical. So as I have already specified, if it is a numerical, yeah, kindly just go for histogram or violin plot, or you can just make use of this box plot. And when coming towards this categorical, yeah, you can opt for count plot or bar graph or pie chart. That would be advisable. Okay, yeah, each and every time I just come towards this to have a summarization. So yeah, let me just go for this univariant analysis. Yes, dear friends, here there are 5 features that are categorical and binary, which we can just say, that is gender, or male or female, married, yes or no, self-employed, yes or no. So like that, we are having these 5 features. Okay, so let me just have a visualization of this. Okay, by each and everything, I am just going to have an all together as a combined data. So kindly just have a note on towards this. So here we have. So this is gender, married, self-employed, histories is there, category history, sorry, credit history is there, and education. Okay. Now coming towards this, yes, dear friend, of course, when coming towards this first plot, 80% application in the data set are male. Yes. And next, of course, around 65% of the applicant in this data set are married. And here, self-employed, yes or no. Of course, here 15% of applicant in the data set are self-employed. And when coming towards this credit history, yes, I just scroll a little. Yes, here 1 and 0 credit history. Yes, here 85% of the applicant have credit history, that is repaid their debits like that. And it is also specified in ones and zeros. And coming towards the education, graduate or not graduate. Okay, so 80% of the applicant are graduate. Okay, now let me just move on towards one by one. So here next it is all about ordinal. Dear friends, there are 2 features that are ordinal, that is variables in categorical features having some order. I have just provided here. Kindly have a view on towards it, and that 2 feature are dependent and property area. Okay, so let me just by using this bar chart, let me just have a view of it visualize it. So this is what. Okay, so when coming towards this, more than half of the applicant don't have any dependent. So dependent 1, 2 and 3 plus, here more than half of the applicant don't have any dependent. And coming towards this, most of the applicant are from semi-urban. Okay, so urban or semi-urban or like this. Here we have, okay. Now let me just move on towards the independent variable, that is under numerical. And yes, dear friends, there are 4 futures that are numerical, as these futures have numerical values as like applicant income. Yeah, of course, this is the one thing having as like an integer, and co-applicant income, loan amount terms, all other things are in float. Okay, let me just have one by one, and in detail we are just going to make use of a box plot. Okay, and not only towards box plot, let me just have the distribution plot and towards box plot of each and every future, 4 futures. Okay, first let me just have this applicant income. So viewing on towards this, so it can be inferred that most of the data in this distribution of this applicant income is towards the left, which means it is not a normally distributed. Okay, so the distribution is rightly skewed, that is positive skewness, you can just specify. So we will try to make it normal in later section, or as algorithm works better, or if the data is normally distributed like that, if you want. And here coming to the box plot, yeah, it confirms that presence of lot of outliers, and yeah, this can be attributed to the income that is disparate in the society, and a part of this can be driven by the fact that we are looking at people with different education levels. Okay, so let us segregate them by education. So here we just have it with this education. And yes, so we can see that there are high numbers of graduation with high incomes which are appearing to be there in outliers also. And secondly, yeah, let's look at the co-applicant incomes also. So here let me have a view of this co-applicant, and of course again the distribution plot and the box plot has been included for this co-applicant. Okay, having the view, yes, we see a similar distribution at that of this applicant income. Okay, so majority of the co-applicant incomes ranges from 0 to 5,000. That is what here, 0 to 5,000. Yes, it is mid. And we also see a lot of outliers in the co-applicant income, and it is not normally distributed. So let me just go for the third one, loan amount. Okay, so here again with a distribution plot and towards the box plot, let me execute it and have a discussion. We fairly see a normal distribution that is still slightly right skewed for this loan amount. Okay, but there are a lot of outliers in this variables, so which will treat the outliers in this later sections. And lastly, let me just have the distribution of loan amount term. So that variable, since actually loan amount term is the discrete variable, we will use frequency. We want to use this frequency to know mainly we can use frequency table, and bar plots also we can make use of it, and which will calculate the number of each category. So here I'm just using this. So these are the exact term, whether 360, 180, 480, 300. So these are the exact terms, and let me view it by bar chart. Not bad. So around 85% of these loans are 360 month. month term, or how come we can just say, yeah, 30 years period. Okay, so now, yeah, dear friends, let me just would like to know how will each futures correlate with the target. Of course, target is our loan status. Okay, so next let me just move on towards this bivariate. And yes, coming towards this bivariant, after looking at every variable individually in univariant analysis, we will now explore them again with respect to the target variable in bivariant analysis. And here, one thing I just want to specify, dear friends, when on just going towards this bivariant, yes, of course, we can just specify it whether that is more than one attribute you are going to compare. So if whether both the variable, both the exact attributes are in numerical, or both are categorical, or one is numerical and another is categorical. So in this form only we have to discuss. So if it in the sense, if it is both or numerical, kindly just go with a scatter plot or a join plot. And if both are categorical, of course, count plot would be suggested. And if one is numerical, another is categorical. Okay, so there are the option as like a bar plot or box plot, or yes, a distribution plot you can just go. And yeah, you can also go for violin plot also there. And these are all some functionalities which we can make use of it. Okay, yes, first of all, let me just find the relation between the target variable and the categorical independent variable. So let us look on at the bar plot, but with an additional information of a stacked bar plot. See, actually, which will gives us a proportion of approved and unapproved load. So for an example, we want to so see whether an applicant's gender will have any effect on this approval chances. In such a case, yeah, you can also make use of that gender functionality. Then we can move on towards it. So for that, yes, this cross tab, it is very much essential. Okay, so let me just make use of that by using this. So here one is gender, and next one it is the target loan status. We have a stacked one, and yes, towards this gender, what we are able to see is, so proportion of this male and female applicants is more or less same for both approved and unapproved. It is somewhat equal, na? Most things are, yes, it is of course 37 and 75, and here it is 150 and 339. But whatever be the count here, when we just go towards this proportion, of course proportion of male and female applicant are more or less same for the both one. Okay, now let me just move on towards whether it is married and with the same stacked bot. So kindly just see here, cross tab I have used, and for married and with the target loan status. Okay, and with the functionality, we are using bar and with the stacked functionality. So let we have a view on towards this. Okay, here yes is in, okay, no, here it is in blue color, but here yes, of course proportion of married applicant is higher for the approved, loan approved. So if it is married, the proportion it is high. Okay, now let me just move on towards dependent. Dear friends, I didn't change any particular functionality, just towards one attribute it's dependent, second one it is loan status, and making it as to make it readable and to be easy to understand. Here I just specified the variable, okay, as like dependence, and with that we are just plotting the bar plot and with the stacked true functionalities. That is what here we have just specified. Nothing much more difference with each and every visualization. Okay, so here when on just moving here, distribution of this applicant with 0, 1, 2 and 3. So kindly just have a note on towards this 1 and 3 plus dependent or similar across both the categories of this loan status or similar. Okay, and nothing much more thing. So dependent yes, and dependent that is to more than 3 plus. Okay. So, okay, fine. Let me just consider this also. And moving on towards this education. Education. So, dear friends, kindly just have look on towards this number and towards this plotting. Okay, so that is what it just shows. And coming towards here, so graduation here it is there and not graduate. And yes, proportion of loan getting approved for graduate is higher compared to not graduate. Graduate is higher. So that is what it is showing here. And next towards self-employed. So self-employed, let I execute. Kindly just visualize the number and towards the chart. It's not bad. There is nothing significant. We can infer from self-employed versus, of course, self-employed versus there is a loan status plot. Of course, nothing significant. We can infer from this. Okay. Next, we are just moving on to this credit history. Okay. Let I execute. Oh God. There is a huge difference. So it seems people with credit history as 1 are more likely to get their loans approved. What a huge difference here. Yeah, we are able to see that. Okay. So next we are moving on to this property area. Property area towards loan status. And yeah, here it is rural, semi-urban and urban. And coming towards this here and towards this, proportion of loans getting approved. Yes, in semi-urban or in higher as compared to that or in rural or here in urban. Okay, fine dear friends. Now let's visualize a numerical independent variable with respect to target. And yes, dear friends, we will try to find the mean income of people for which the loan has been approved versus the mean income of the people for which loan was not approved or rejected. Let me just have a view. So loan status, applicant income. Well, let me just have a view of mean and let me apply it by the plot. Okay, so here, yes, dear friends, the y-axis represents the mean applicant income, and we don't see any significant difference in this mean income between those approved and not approved. Okay, and kindly just have a note, it is 5,446 and 5,384. There is not much difference. Okay, so yes, let me just make some bins for that applicant income variable based on the value in it. Okay, so analyze the corresponding loan status for each one. So low, average, high and very high, and let me just create a bins as like 0, 2,500, 4,000, 6,000 and 81,000. Okay, so here this exact bin. And when on making, let me just view that and let me just have the beans. Okay, of course we are not able to see that beans. Okay, but anyhow, let me make use of that visualizing towards stacked bar plot. So kindly have a view. Okay, so low, average, high and very high. We have that yes and no numbers 26, 57. Oh god, average it is 123. And here 32, 79, 39 and 73. Okay, so it can be inferred that applicant income does not affect the chances of loan approval, which contradict our hypothesis, in which we assume that if the applicant income is high, the chance of loan approval will also be high. That is what. Okay, so yeah, we will analyze the co-applicant next. So co-applicant and the loan amount variable also. Okay, so here, yes, again we are just going to make use of that bins with the same similar manner. Okay, so here we are just going to make it as a bin, and with that let me just make the plot. Okay. But before discussing on towards the plot, I just want to have one more view towards the percentage of the co-applicant, because most the thing we are not able to view the percentage. Yeah, kindly just see here, percentage 0. Okay, so yeah, it shows that if co-applicant income is less, the chance of low unapproved or high. Oh god. Okay. So, but this does not look right now. So the possible reason behind this may be the most of the applicant don't have any co-applicant. So the co-applicant income for such applicant is 0, and hence the loan approved is not dependent on it. So we can make a new variable in which we will combine the applicants and the co-applicant. Okay, so to visualize it, so here let me just create a new variable, total income, combining applicant income and co-applicant income. Okay, so let me just make it, and with that again I'm just creating the bins and viewing it. Let me, okay, so here, okay, low, average, high and very high. So we can see that proportion of getting approved for applicant having low total income. Okay, so low total income is very less as compared to that of applicant with the average, and high and very high income. That is what. Okay, so this is more consistent with our hypothesis with applicants with high income will have more chances of loan approval. So if you are having high income, of course the loan would be processed. Okay, so that is what. Okay, what about the loan amount? Yes, of course, dear friends, here also we are just going to make use of this loan amount within a bins, and let me have the plot. Okay, so this is the plotting which we have. Okay, so see here, it can be seen that proportion of approved is higher for this low. Is it so? Yes, low, and average loan amount also. Yes, as compared to that of high, this both are somewhat equal. Okay, so which supports our hypothesis, in which we consider that the chance of loan approval will be high when the loan amount is less. We can also have this. Okay, yes, dear friends, now what is the thing is, let me just drop this bins which we have created to make this exploratory part. Okay, so because we want to go for further, so I just want to before dropping, let me just have a view which I want to drop it. Yes, here of course we want to drop this income bins, we want to drop this co-applicant, loan amount bin, and total income bin and total income. So this total income we have just added that applicant and co-applicant income. So that is what. So let me just drop, and I just want to move on towards this multivariate. See, actually here before going on towards that, multivariant, I just want to have a view of this head, what it is. Yeah, I think this is what the original training data. And secondly, when on just going towards this dependent, see, actually we have this as like 3 plus. So kindly just have a note of it, this 3 plus. So we will change the 3 plus in dependent variable to 3 to make it a numerical variable. So we will also convert that target variables categories into 0 and 1 so that we can find its correlations with the numerical variables. Okay, so one more reason to do so is, see, actually few models like logistic regressions takes only numerical values as input. So we will replace this no and yes as with the dependent. To see, actually here we have no and yes, and we are just going to replace it with 0 and 1 with correspondingly. So here kindly just to see here difference, this one I want to replace this dependent, this 3 plus to 3, and this lone status, this is our target. So yes and no, here I'm just going to specify it as like ones and zeros. Okay, now finally let we have this head. So the top 5 records. So here we have our data. Okay, so dear friend, when on just viewing on towards this multivariant, of course you know about this multivariant functionalities. So more than 2 variables. If it is 2 variable, it is bivariant. So more than 2 variables, if you are analyzing it, yeah, it is specified as like a multivariant. Okay, and again towards this multivariant, yes. So last but not least, we are just going to see on towards multivariant, and towards this multivariant, what are all the plots which is very much essential. It is bar plot, you can just go pair plot, you can just make use of it. Heat map, of course, this is what the most highest used, and histogram also you can just go ahead. But yeah, when on just towards this histogram, you are not able to see the outliers. But anyhow, yeah. Let me just discuss about this correlation. Okay, so now let we just yeah, let's look for the correlations between all the numerical value. So we are just going to make use of this CO or that function to compute pairwise correlations of column executing whether even of course this excludes null values using Pearson correlation coefficients, and then we will use this heat map. Okay, so we are just using the heat map to visualize the correlation, and heat map visualize data through variations in coloring. So that is what the main thing. So here we have used that C map. Okay, so the variables with a darker color means their correlation is more. Okay, so let we just have this aids about the matrix, and next here we have the correlation. Okay, we see the most correlated variables are the first one here, it is applicant income and loan amount with correlations of 0.57. Next one, credit history to the loan status with correlations of 0.56. And next, loan amount is also correlated with co-applicant. Okay, so co-applicant with correlation coefficient of 0.19. Okay, so this is what we have analyzed about the data. But till now, yes, we have just discussed only about univariant, bivariant and multivariant analysis, and we also learned various ways of plotting the data by using this matplot and cplot thing. And kindly just have a note, dear friends, the graph discussed in this session are not the only graphs available. Based on the use, you can decide which graph to use. And you can also uncover variable or valuable insights, spot trends, and detect any issues in your data before moving on to modeling. Because once from this analysis only, you have to think whether your future has to be transformed or not, whether you want to scale it or not, or which future you are going to select it or not. Yeah, that is what very much important. So to understand about the data, this exact visualization, I think it would be very much useful. And yes, dear friend, kindly just make a like if you like this video, and yeah, share it to others. If you are not yet subscribed, kindly subscribe the channel, and see you in another video. Thank you, dear friends, and happy learning.